Throughout this lecture, we will be able to identify alternative research designs that have been performed in kinesiology and health-related sciences. We will also be able to describe the general tenets of historical and philosophical research designs. We will also be able to explain the similarities and differences between experimental and epidemiological research, and also compare and contrast the types of a single subject design research. And lastly, we will be able to explain the concept of effect size in relationship to meta-analysis. At many universities throughout the world, exercise physiology researchers are actively recruiting and testing participants to examine the effectiveness of an intervention, such as resistance training or cardiovascular training, or they are comparing groups of similar individuals on some health-related measure, which can be related to body composition, blood pressure, or some sort of fitness parameter. Majority of researchers will commonly perform experimental and descriptive techniques when researching, but there are also other types of research which provide valuable information about health and movement. Some other techniques or methods of researching are historical research, epidemiology, single subject, and meta-analysis. All of these differ in their methods, but they still serve to answer an important question or questions, such as how does exercise benefit type 2 diabetes individuals, for example. They all still provide a logical research design with systematic data collection and represents valid areas of interest. Historical research is using information from the past to understand two different areas. The first is that historical research attempts to capture the thoughts, attitudes, and behavior about physical activity during different periods in recorded history. And with historical research, this leads us to the origins of the study of kinesiology and other health-related science areas. Also, it helps us understand why certain practices or belief systems came into being. Another part of historical research is that it can uncover viewpoints of different researchers from different areas. So in this case, you can see how one researcher thought about physical activity back in the 70s and compare their thoughts and beliefs to a researcher today. The second purpose of historical research is to provide a framework for understanding issues and attitudes about health in the present by looking at the past. This can help us avoid problems encountered in the past, such as, why was one country better at controlling a certain disease, such as the West Nile virus, compared to another. Historians have certain methods of data collection which they will often refer to as evidence, which is historical data or artifacts. Similar to experimental research, historians also start with a problem question or research question and then creates a study design. Just recording facts from earlier times is not historical research. So historians collect evidence in a variety of different sources. One of them is called primary sources, which is firsthand evidence from the time under question. This can include photographs, medical equipment, interviews, journals, official records, or material culture such as some sort of ad back in, say, the 80s. Also, it can include tools. It's preferred that these researchers use primary sources because it provides a first-person glimpse into the time or event under study rather than someone else's reinterpretation. This is somewhat similar to writing a literature review where you want original papers or original studies in your literature review. Another way that historians collect evidence is through secondary sources, which is evidence based on primary sources, such as obtaining information from someone who did not witness it, but gathered evidence about the events. Some examples include books, magazines, and even journal articles. One thing, though, with secondary sources is that you should use caution, as they must be sure to take into account any subjective biases that the authors or someone may have had in creating the secondary source. After historians begin to collect primary sources of evidence related to their question, they begin the process of external and internal criticism, which involves looking critically at the evidence to check its validity. External criticism is establishing authenticity or legitimacy of the evidence. So really, you are seeing if the evidence is real or if it has been altered. There are different ways to establish this, such as carbon dating or comparing handwriting. After external criticism, the process of internal criticism starts. Internal criticism is establishing credibility. So, is a piece of evidence consistent with other pieces of evidence during that time period on which you're collecting? After everything is completed, historical research pieces all the evidence together and then tells a story to provide the best possible answer to their question. Philosophical research is sometimes associated with historical research. Philosophical research is the scholarly pursuit of the nature and meaning of knowledge. How this type of research differs from experimental research is that it does not physically test anything and quantitatively assesses the results to determine causation. So philosophers really do not gather data per se or use statistics to provide some objective interpretation of the results, but they look to understand meanings through reflection. And reflection is the process of actively thinking through a problem using logic and reason to explore it. The process of performing philosophical research consists of a 3-step process which allows for systematic reflection. And these steps are, 1, develop a thesis, 2, clarify the problem, and 3, search the arguments. 2 common ways to analyze philosophical problems is through inductive and deductive reasoning. So we touched base on this reasoning process earlier in the semester. But inductive reasoning is deriving general conclusions from specific observations. It is the process of building theories based on a small number of specific observations or examples. So say, for example, clinicians gather, a series of symptoms to attempt to diagnose some sort of injury or a disease. That is an example of inductive reasoning. The example we used earlier in this semester is where the premise is my dog is cute, and the conclusion is that all dogs are cute. When we look at deductive reasoning, this is reasoning from a general theory to derive expected outcomes. This describes as a kind of top-down approach using deductive reasoning. So an example of deductive reasoning is a clinician starts with the premise that a patient has a particular condition or some sort of disease, and then they look for the specific symptoms to confirm that. Another research approach is epidemiology research. This is where epidemiologists study health as it relates to populations. In general, this is often utilized in public health. But epidemiology research is the study of determinants of incidence, distribution, spread, and control of disease and health. So this is where epidemiologists want to determine why are some people healthy and others are not. So is it due to socioeconomic status? Is it due to nutritional intake or physical activity levels? And lately, there has been an increase in physical activity epidemiology and how it affects different populations. The reason is that we have this increase in overweight and obesity throughout the country, and we want to try to determine the best strategy to kind of reduce this rate. And also looking at physical activity can help with the aging process and determine which variables or areas we need to kind of focus on. So epidemiologists study the relationship between exposure to something that impacts health and health outcomes related to that exposure. Remember that one of the key sounds to experimental research is internal validity. The one way to maintain internal validity is by examining a relatively small homogeneous sample. But with epidemiologists, they are interested in the overall population. So they sample from a larger heterogeneous participant sample to make up the population as a whole. Epidemiology research also differs to experimental research in that it focuses on the natural progression or history of exposure to risk factors and then also health outcomes. Since epidemiology examines diseases and health determinants, they can use either descriptive or analytical methods. Descriptive epidemiology examines patterns and trends in a relationship among different individual characteristics such as age, weight, and also specific disease or health conditions. Remember, with descriptive research, there is no attempt to intervene or manipulate anything. Descriptive epidemiology data is acquired through survey or existing databases. Once this is required, they will then divide it into groups to meaningful cross-sections and look for relationships within them. This is often referred to as cross-sectional designs. And with cross-sectional designs, this will require a large number of participants. Analytic design allows researchers to establish cause-effect relationship between determinants and outcomes. Epidemiology researchers use 3 different analytic designs. The first one is cohort, the second is case control, and the third is randomized control studies. Cohort studies or prospective studies take place over a significant period of time. So how does current exposure of something lead to outcome disease in the future? During this type of analytic design, researchers will identify a population of interest and select a cohort from that population. However, the cohort must be diverse and specifically must vary in their exposure to the risk factors under the study. The researchers will then measure baseline risk factors and outcomes and then follow the cohort over time to see what the impact of that risk factor has on certain measures of health. So they are going to be periodically checking for outcome disease. There is a way to determine whether or not you will get the disease, and this is called relative risk. Relative risk is the probability of developing a health condition based on exposure to disease determinants. Relative risk is calculated by dividing the incident rate for those exposed to the risk factor by the incident rate of those who were not exposed. Here we can see the formula on how to calculate the relative risk. If relative risk equals 1, there is no association between exposure and outcome. If the value is less than 1, there is a negative association, and if larger than 1, there's a positive association. In case control studies, researchers look at the characteristics of individuals now, focusing on varying levels of the health state of interest and looking back in time at exposure levels of different risk factors. This may also be referred to as retrospective research. In this type, researchers create groups with the case such as a health or disease state and also create a control group with no health or disease state. Here, you may survey groups on past exposure to the risk factors relating to the outcome. After comparing the cases to the controls, researchers will calculate a measure called an odds ratio. An odds ratio is a ratio of the odds of developing a health condition in the case versus control group. In an odds ratio, the number of people exposed who do have the disease state is multiplied by the number who aren't exposed who don't get the disease. This number is divided by the number exposed who don't get the disease times the number of people not exposed who do get the disease. We can interpret this odds ratio number in the same way relative risk is. The last type of analytic design is a randomized controlled trial. Remember that one of the hallmarks of a true experimental design is the randomization of participants. The randomized controlled trial studies also use this process and provides an intervention and uses a control group to examine the long-term effects of a treatment. There are some differences though between true experimental and randomized control studies. One is that true experimental designs rely on a small number of participants with similar characteristics to help improve internal validity, while randomized controlled studies rely on a large number of participants with divergent characteristics to improve external validity or generalizability. However, both represent the best method of assessing cause-effect relationships. In a randomized controlled trial, a researcher will randomly assign the participants to either a treatment or control group. The experimental group will receive the treatment, while the control group receives a placebo. One thing is that the experimental group may receive a novel treatment, while the control receives the traditional treatment. So the effect of the treatment occurs naturally over time, and outcomes are measured at different time points after exposure to the treatment. Then the results are compared between groups to determine how exposure impacts the outcome. Here's a figure that compares the different types of analytic designs in epidemiology. Exposure and outcome are represented at the top of the figure, and the arrows represent the direction in time that a study progresses. In a cohort study, researchers take measurements and then follow the participants over a period of time to see who develops a disease. In case control studies, researchers match participants who do or do not have a particular disease and then look back and examine the history of exposure to the disease risk factors. Finally, a randomized control study randomly assigns individuals to either a treatment or intervention group or a control group and compares outcomes of these groups at specific time intervals. With experimental design, a researcher may examine two groups of participants, pre-test on an important dependent measure, apply treatment to one group, and then post-test on that measure and look for statistical differences. There are some assumptions with this research, but one is that the groups initially look similar in that the treatment causes a relatively uniform effect. The use of single subject research is when there is a high degree of individual variability in performance. Single subject design research involves examining either a single or small group of participants. And this is very similar to case studies since it also uses single or small group of participants. However, there are some differences between the single subject research and case studies. One is that the researchers provide an experimental intervention or treatment. And also, in single subject research, a baseline must be established for the dependent measure under study prior to intervention. This way, we'll have the participants act as their own controls. There are a variety of study designs to choose from when using single subject research designs. The simple baseline design is the most basic. In this design, the researcher establishes a baseline of the dependent measure of interest. This period is called the baseline phase, which is similar to the pretest in experimental research. One thing though is that to establish a baseline, researchers have to test and retest a participant a number of times and show consistency in the results. This is performing at least 5 trials. After establishing a baseline, the intervention or intervention phase is provided, and the participant is retested to see if any changes occurred. A downside of simple baseline design is it will not allow for the assessment of causality. So there are other designs in which researchers can utilize. One design is a withdraw design, where after the intervention phase, the intervention is removed. The researchers will then look for another change, such as either a return to baseline or a change from the intervention phase. Another design is the reversal design. This design provides and then withdraws the intervention in 4 phases. So in this, the researchers want to know if you reintroduce the intervention, does it go back to the previous intervention phase? There are some issues with this type of design. First is what if the effect can't be reversed? And due to this, once the intervention is taken away, it won't lead to a return back down to baseline. Another issue is what if the intervention leads to such positive change that it would not be in the best interest of the participants to take away the treatment. A type of design that avoids some of those issues with reversal designs is the multiple baseline across subjects. This uses the simple baseline design on more than one participant at the same time. This allows for individualization of establishing baseline and also treatment. Also, this design requires the researcher to examine at least 3 participants. All of the participants are tested on the dependent measure, and a baseline is then established. So the first participant who shows a stable baseline will then receive the intervention, while the other participants continue at baseline. Eventually, the participants are given the intervention. The way in which a researcher demonstrates the effectiveness of the intervention is to show the effect across different participants. Here, the figure on the right provides a hypothetical multiple baseline across subjects design with 3 participants. With participant 1, they receive their treatment after establishing a baseline in 5 observations. Participant 2 receives treatment after 7 observations, and participant 3 after 9 observations. And as you can see, the intervention period lasts differently as well. Depending on the area, there are over 100 plus research studies. An important aspect out of the research studies is not all are created equal, meaning that not all of them are good as far as their methods, their study design, or their validity, etc. One way to objectively assess all the studies is through meta-analysis research. This allows for an objective approach to synthesizing the results of multiple existing research studies. In the past, we discussed the difference between a meta-analysis paper layout compared to an original research paper. A meta-analysis goes a bit further compared to a review paper by systematically evaluating all existing studies on a particular topic using a number of criteria, and then making conclusions on the effect size of the independent variable based on the results and about the generalizability of the effect. The effect size is the strength of the intervention based on the results. And overall, the meta-analysis can still be published in research journals. A thing with meta-analysis is that there are aspects to consider. One of them is that the researchers must determine the inclusion criteria for the studies of interest. This is similar to the inclusion criteria to participate in a research study. So for example, if you want studies that look at changes in muscle size via ultrasound, then anything not measuring that will be excluded. Next is that the researchers locate all the published research based on the criteria that they have selected. Once they obtain the studies, they then evaluate the studies more thoroughly and remove those not meeting the criteria. A critical component for inclusion for a meta-analysis is the presence of effect size, which is either provided in the study or where the researcher can calculate it from the study itself. The next step in performing a meta-analysis is coding the data. Prior to coding, the researcher must determine what the key components are that could influence effect sizes reported across the studies. Lastly, after analyzing, researchers are to interpret components and effect size and also make their conclusions. Effect size is a measure of the strength of a treatment. This is really referring to how meaningful is the difference between two groups. If the treatment has a big influence on the dependent measures, then highly meaningful differences exist between the treatment group or experimental group and the control group. We can calculate the effect size by the mean score of the treatment group minus the mean score of the control group, then divide that by the standard deviation of the control group. An effect size of 0.2 is considered small, 0.5 is moderate, and 0.8 is large. The effect sizes are then included in a table or figure in the paper. But once the effect sizes are calculated, then a mean of the effect sizes for all of the studies is then calculated. We can then use this average on making a conclusion of the topic. The only thing that needs to be completed by Monday, November 2nd by 11:59 p.m. is completing exam 1. There is no quiz over Chapter 9 on which we just went over. But again, please remember to take exam 1 as this is due by Monday, November 2nd by 11:59 p.m.